Hello again. So hopefully you've just seen the presentation going through the AQA syllabus for databases. I thought it'd be useful to show you a bit of a demo. So we're not going to go through everything, but we are going to go through quite a bit. So hopefully it will all make sense. So I'm going to do this demonstration on Windows using SQL Server. This is SQL Server Management Studio. I've chosen SQL Server because it's very pretty to look at. The tool is very nice to use. It's very quick. It's very user friendly. But most of the database products are very similar, and they have very similar tools. I'm going to stick with the school and teacher scenario. I've expanded it a little bit. So on the left hand side here you can see under databases I've created a teaching database, and there's currently no tables. This is what I'm going to create. So I've got teachers. Teachers are related to classes. A class has a subject. We have students. Students can attend one or more classes. Now we need the special mapping concept in order for a many-to-many relationship. So many students can attend many classes, and many classes can be attended by many students. So we'll go through that in a bit more detail in a bit. We also have included exams and exam results as well. So we'll go through how we create this database. So you can create tables using the tool in SQL Server. So you can do it through right-click tables, new table, and actually doing it through here. But I prefer doing it as text because I know exactly what it's doing. I can then script it, I can copy it, I can do it again very quickly later on, and it shows you exactly what it's doing behind the scenes. So in order to create a table, create table teachers, pretty self-explanatory. So within the brackets I say what I'm going to create. So table called teachers. I have a teacher ID column. Int is my data type, so it's an integer. An integer is just a whole number. Identity means it's going to be an auto number. It's going to start at 1, it's going to increment by 1 each time. And this is going to be my primary key for this table. Okay, remember that primary keys from the presentation are my identifiers for that table. I'm going to have a title column. Varchar is variable character, and it's going to be a maximum of 30 characters long. And I've said not null, so this column must have a value in it. First name, again, variable character 30. Surname, variable character 30. Date started. Now there's a special date type, which I'm going to use. Now every teacher must have started, so it does make sense for it not to be nullable. So I'm going to make that not null. However, not every teacher will have left yet, so I'm going to leave that as nullable. Okay, so if I don't say anything, if I don't have a not null at the end, then it is assumed to be nullable. Subject just has a subject ID and a subject name. You can make this wider if you wanted. You can put more information in there if you want, but I'm just keeping it quite simple. Classes, again, class ID, my primary key. Class name. Now here's our first foreign key. So a class is a subject ID. So you can have multiple classes for a subject. So you can have maths 1, maths 2, for example, all different sets. So my subject ID is a number. It's a foreign key, and it references the subjects table, which is this one, and that's the column that this one matches. Okay, and that's not null because every class must have a subject. Similarly, taught by teacher ID is a number. It's a foreign key and it references the teachers table and the teacher ID column. However, you may have a brand new class that hasn't got a teacher yet, so I've left that as nullable. Okay. We've got a students table, student ID. I'm going to set that to start at 1,000,001 because why not? And it's going to increment by 1 each time. In fact, I'm not going to do that. I'm going to start it at 100,000. My first name is variable character 30 characters, surname, again variable character 30 characters, and they're not null. I could put other fields in here to further describe students if I wanted, like current address, but I've just left it as it is. This is my student class map. So this is a bit interesting, this one. So I've got two columns, a student ID and a class ID. Now both of these are foreign keys. They both look up into students and classes, and both of them make my primary key. Now previously we've just seen primary keys defined like this in line, but if we've got two columns that make up my primary key, we need to do it slightly differently. So we need to create a constraint. We need to name it. It is a primary key constraint, and these are the columns that go into it. So what this means is that we can have the same student ID multiple times, we can have the same class ID multiple times, but we can't have the same pair multiple times. Okay. Exams. Again, this is exam ID, exam name, exam date, also pretty similar to what we've already had. Subject ID. Again, so an exam has a subject ID. Foreign key references subjects. And it doesn't make sense to have an exam without a subject ID, so that's not null. Our exam results, again, so we have an auto number as our primary key. We have an exam ID that result links to, student that actually sat that exam, and a percentage. Now percentage might have a decimal point in it, so we can't use a float, so we use a float instead. A float is a floating point number, and allows us to have points. Okay, I'm going to make that not null. And the same for these as well, because I've missed them out. There you go. And what we're going to do is create a constraint on our percentage and make sure it's a sensible number. So we're going to name it CHK exam results. This time, instead of it being a primary key constraint, it's going to be a check constraint. So check constraint is a different kind of constraint, and it checks that values are within a limit that we define. So I'm going to say that score percentage must be greater than or equal to 0, and score percentage is less than or equal to 100. Okay, so we now have our tables. So let's go ahead and run all this. Hopefully we've got no errors. There you go. So commands complete successfully. If I refresh this, I should have. Oops, sorry. Let's run this in our teaching database. Run. There you go. Tables. Refresh. There you go. So I now have my tables created for me. And if we go to classes, for example, we can go through columns, a list of columns, a list of keys, constraints, and so on. Okay. So the next thing to do is to insert data into our new tables. So because of our foreign keys, there's now a certain order that we must insert data into. We can't, for example, insert into classes yet because a class must have a subject ID, and we don't have subjects yet. So let's start with subjects. We're going to insert into subjects, column subject name, the value computer science, physics, maths and French. Okay, so let's do that. Now what we can do is have a quick look at what that table looks like from subjects. Now you'll notice that I've used star. Star means give me everything. I could have equally said select subject ID and subject ID and subject name, and it'll give me exactly the same thing. Just stars much shorter. Okay, so you'll see me doing this quite a few times throughout the demo. See exactly the same thing as actually naming all the columns themselves. So you now see my table has 4 rows. So these are the auto numbers. Despite me not telling it what they should be, because when we defined the table, we said that subject ID is a primary key and it should be an auto number. It's created these numbers for me. Okay. Next thing we'll do is insert into teachers. So we've got 3 teachers we're going to create it. Again, 3 of them haven't left yet, but 1 of them has. So we've got 3 teachers inserted. Like that. Then we will insert into classes. Now, classes, we need a class name, a subject ID, and a taught by teacher ID. So if we do select star from subjects and select star from teachers, we can get those on the screen so that when we're writing these, we know what values to put in them. Yeah, so we're going to say that subject ID 1, computer science, taught by teacher, teacher 1, Dr. Claire Evans. Yeah, Dr. Claire Evans is going to teach computer science 1, computer science 2. She's also going to teach math 1. Notice that math is subject 3. Okay, so we've got a few teachers teaching that, so we're going to run that. We're then going to insert some students, so 3 students, really unimaginatively named. Now, if I do select start from students, if you remember, our student ID column was defined as starting at 100,000 rather than 1. So here we go. Now, what we're going to do is we're going to define which students attend which classes into our mapping table. So we're going to insert into student class map, student ID, class ID, values, and then the student ID and the class ID. Okay. We're then going to create some exams. So GCSE Computer Science 1, Computer Science 2, Physics 1, Maths 1, French 1. And then finally, what we'll do is we'll have a bit of a look at what we already have before creating some exam results. So we've got our exams here. We've got students, we've got classes, student class map, and currently no results. Okay, so I'm just going to insert some exam results into those tables. You just have to trust me for a minute. So let's have a final look at everything. So what we've got now is 1, 2, 3, 4, 5, 6, 7 tables, which is 1, 2, 3, 4, 5, 6, 7 tables. Okay, so we have 7 tables with some data in. Now what we'll see is it's quite hard for us to actually make sense of all this because it's 7 distinct tables, there's numbers all over the place, and it's quite messy for us to read. So we need to ask a question of it, of the database, so that we get something sensible out of it. So my question is, show me all of the, show me the student first name and surname, the exams that they sat, their scores, and where the scores are greater than 50%. Okay, so what I'm going to do is I'm going to select, start this again. So I normally start with select start and then work down from there. It's easier. So if I select start from exam results, okay, and that's just going to give me that. So what else do we need? We need to join against exams on exam results dot exam ID equals exams dot exam ID. Okay. I also need to get the subject from the exam table. So join subjects on exams.subjectID equals subject.subjectID. Join students on students.studentID equals exam results dot student ID. What that going to give me so far? Let's have a look. So what we'll see here is it's produced us all the information we could possibly need, but very, very wide. Yeah, so it's just it's bolted these 1, 2, 3, 4 tables on side by side, and they've matched the numbers together. So, for example, exam ID and exam ID. Yeah, these all match. Yeah. We'll see that our score percentages are here as well. So there's score percentage, exam names, student IDs, student information, subject name, everything we need, just not in the right order, and there's a bit too much information as well. So what we're going to do now is replace the star with students dot first name. We'll put a new line in here. Students dot surname. Exam dot exam date. Now we'll do exam results dot score percentage. What else did I have? Subject name. What else? Subject name? No, we don't have a subject name in there either. So let's put a subject name. So let's do subjects dot subject name. Now let's look what that looks like now. You can see that the user interface is telling me when I do things wrong. So now we have something which is a lot more useful. So we have first name, surname, exam date, score percentage, and subject name. So we should probably include our exam name in there as well. Exam name. Run that again. There you go. Okay. So what we now want to do is order it. So let's put an order by in there. Order by, let's say, subject name, then by exam name, and then by score percentage. Now we're going to say it's score percentage descending. So if I don't put descending in there and leave it blank, that'll be ascending by default. Or I can explicitly say ascending, but I actually want descending in this instance. So let's see what that does now. So what that's done now is sorted by subject name in alphabetical order, then exam name. So you see computer science is first, then all the ones and then the twos, and then it's sorted by score percentages in descending order. Yeah. And now finally, I want to put a where in there. Let's say I want everyone where the score percentage is less than or equal to 90%. So I've currently got 7 rows. When I take out those who have above 90%, I should have fewer. There you go, I've now got 6 rows. If I flip that round and say greater than or equal to, let's say 70%, I should have a different set of rows again. So I've now got 3 rows. 2 different exams, in computer science. So what you can see is that we've built up quite a complicated looking query quite simply. We've thought about what it is we want to see, and then you just build it up logically. And that's all there is to it really. There's a lot of functions, different things. So we can do averages, for example. So we could say, rather than give me all this lot, we can say select exam name, or let's say select subject name, average, exams, exam results dot score percentage, average score percentage. Like that. And you'll now see that we get a average score percentage and subject name. There's all kinds of these special words. So the average, there's, for example, rounding things. So we do round as well. Expression 2. I think that should get rounded to 2 decimal places. There you go. There's all kinds of things which I can do, and it's so powerful. This is just really an introduction to show you how easy it is to do it. And I really encourage you to go and download one of the many databases out there. Most of them are free, especially for home use, and go and have a play. Model something which you can imagine and know well, so teaching or a shop, for example, or maybe a weather station, and see what you can do with it. Okay, thank you very much for listening. I hope you have many hours of fun.